Good morning. Welcome to Current Scum World. In this video, we'll see what is called critical micelle concentration, that is CMC, what is called KRAFT temperature, how CMC is determined, and what are the factors affecting it, what are the importance of micelles. Okay. Micelles are called associated colloids. Micelles are called associated colloids because they are the soap molecules or the detergent molecules are associated to form spherical ball-like structure called micelles. Okay, these are called micelles. They are associated, so they are called associated colloids. Micelles are called associated colloids. Now, what are surfactant? Surfactants are nothing but soap or detergent. What are soap? Soaps are sodium or potassium salt of long chain fatty acid. Long chain, see here, this is long chain fatty acid and this is acid group. Okay, so you have in surfactant you have two groups, that is one is hydrophobic. This tail, the hydrocarbon tail, hydrophobic, that is lipophilic tail. Okay, and the head, that is carboxylic acid group, that is hydrophilic, water loving or fat hating group. Okay, so there are two parts in surfactant molecule. They are hydrophobic tail and hydrophilic head. Okay, now what will happen when surfactants are added to water? When surfactants are added to water, they form aggregates, that is called micelles. Okay, now at what concentration these micelles are formed? That is called critical micelle concentration. So it is the critical micelle concentration is the minimum concentration of the surfactant are added to the solution at which micelles are formed. Okay, so this is the minimum concentration of surfactant at which micelles form in a liquid when surfactants are added to the solution. Okay, what is called KRAFT temperature now? The formation takes place only above certain particular temperature called KRAFT temperature. The CMC, that is the micelles formation, takes place only above a particular temperature called KRAFT temperature. Okay, on dilution, suppose when you dilute it further, the micelles reverts back to individual ions. Okay, reverts back to individual ions. Okay, what will happen when you add excess surfactant even after the formation of micelles? All added surfactants will also form micelles only. Okay, how it is determined? How the critical micelle concentration is determined? It is determined by conductivity method. Okay, we will see now. It is very easy. Critical micelle concentration is a key parameter in colloidal and surface chemistry. It's an important parameter used in colloidal and surface chemistry, because at this concentration the colloidal particles are formed. It is important for understanding how surfactants behave in liquids. It is determined by the critical MICELLE concentration. MICELLE concentration is determined by measuring the conductance of the surfactant solution with the increasing concentrations added to it. Okay, so let us take a beaker and water. You add 1 gram of surfactant, 2 gram, 3 gram, etc. Okay, with the increase in concentration. As you see, the conductance increases with the increase in concentration. After particular concentration, the conductance increases does not vary very much. The conductance does not increase very much. Okay, so there are two straight lines obtained. From the intersection of the straight line, the CMC, the critical micelle concentration is the concentration at which the micelles are formed. This is the minimum concentration at which the critical micelles are formed. Okay, so the conductance increases sharply first due to conductivity of surfactant free ions. Once at this point, at this concentration, the surfactant molecules are aggregated to form micelles, a spherical structure. The conductance will be less because of aggregation, because of association of surfactant ions. So what are the features of CMC? The stability of micelle is obtained from CMC. For example, higher CMC indicate lower stability, whereas at low concentration micelles are formed, then it is more stable. The micelles are more stable. Surface tension, it is used to determine minimum amount of surfactant needed to reduce water surface tension. Okay, so at CMC, when micelles are formed, the surface tension of water is reduced. Okay, so CMC is used to determine the minimum amount of surfactant required to reduce water's surface tension. Okay, what is the structure of micelle? It is spherical in shape. Okay, micelles are spherical structures with the hydrophobic pointing inwards, because surfactants are dissolved in water. Okay, so the hydrocarbon tail are pointing inwards, whereas hydrophilic head pointing outwards. They form outer cell. Now, what are the factors affecting CMC? Hydrophobicity, glass transition temperature, and ratio of hydrophobic length. Okay. Thank you for watching. Please share and subscribe. Thank you again.